So yeah, welcome Yann and colleagues. Thanks very much for accepting our invitation to give us a talk today. So I'll read out your title and then let you get started and introduce yourselves. Co-creating and evaluating AI models in the African context, examples on ASR, bias evaluation and LLM testing. Over to you.
Thanks so much. Thanks for the opportunity to be able to share with you. I mean, as a company and as researcher, and not only based, across several countries in Africa, for us, it's key to be able to interact with other people in the field, notably to be able to get this more academic perspective, some time of the work that we do that is very practical. So thanks for making the time. Indeed, several topics to cover. Just to give you the gist of some of the things we're working on, but if I had to summarize, it's basically trying to find the intersection between social science, what we've been doing in the last 8-9 years around, user research, behavioral research on health education and so on across Africa, and the intersection with AI system. And overall, how can we build AI system in these domains that are very relevant for the African context in plural. This is the team we have today. Some of them may have like connection issue and may join later on. But you will see like they introduce themselves while we start, some of the presentation. Anthony, who's a machine learning engineer, will start introducing the work on ASR. And then after we'll have Oche, who's a machine learning engineer as well. We're going to talk about, bias evaluation and a project we call Afristereo. And if she has connectivity, otherwise I'll step over for her. Mam Kumba can introduce how we scale LLM testing, notably multi-turn evaluation of LLM. All right, so without further ado, briefly talk about UCREL and where we come from. But basically, we are a social researcher, meaning like we do qualitative research. And if you are in the field of psychology, if you have psychology colleagues, you know that very well. So it's the same type of research that ethnography and some anthropology. In the tech world, we call that UX research. In the development sector, we generally call that human-centered design. But basically, it's a set of methodology that help us, understand the population, their behaviors. And then the design part of things is really creating solutions that are already tailored. And so we've been doing that for the tech world. So the Google, the Meta, the TikTok of the world. But also the development sector like the Gates Foundation, the UNICEF, and so on. And this is leveraging all these learnings that we started working more and more around artificial intelligence. And we tried different things, but basically sitting at 3 different levels. The first one was on ASR, because, voice is definitely one of the key for the development of many sectors across the African continent. And so we thought like we need to understand how ASR works and how voice collection works and training and so on. So we created a project that is named Nakala that's still continuing right now. The second layers is around evaluation, and notably evaluation of the model, so benchmarking, as we usually call it. And so what is the methodology to create relevant data sets for evaluating different features of different models, but notably for us with the lens of the social norms and the cultural context, and how can we make sure that we can have a scalable way of testing models on the cultural aspects of one country, of one use case, and so on. And then after the third layer is a bit more evaluating how people use AI. So it's less involving machine learning per se, but it's more looking at the trust barriers, the behaviors that people have. And so we do some research around, the use of AI for mental health with the lens of religion, or another study on the trust itself of AI system. But that's just the gist, and you'll understand probably much better if my colleague share what they do. So I guess over to you, Anthony.
Oh, hello, everyone. Can you hear me?
Yep.
Great. So we are going to talk about this project, Nakala, which is a Wolof ACR for reproductive health. Automatic speech recognition is a technology that turns speech to text. It works for big languages like English or French, but for many African languages, it doesn't not work well. So this creates like inequality where million people cannot benefit from this technology. So this is a big problem, especially in healthcare. because where voice is very important for nurses, patients, and for doctor. And we know like Wolof is about it is spoken in 3 countries, about 12 million people. And even though this language is spoken widely, it does not have enough digital tools. So this is like a gap. We identify like 2 critical gaps. So the first gap would be the domain-specific accuracy gap, because more ACR models are trained on everyday speech. As a result, they perform poorly when they expose to clinical or medical vocabulary. And the second gap is the social cultural context gap. Current model often struggle with regional accents, code switching, and the culturally specific expression. So when they are training, where training data is not representative, certain community may be systematically misrepresented or excluded. And this can lead to a bias. And this really matter because the current model are not reliable enough for the healthcare use. And we know in medical situations, mistake can have like a very serious consequences. That is why domain adaptation is very necessary. And also existing systems are not as sufficiently reliable for healthcare application, where the accuracy is very crucial. So what we did, for this project, we did not only import an existing speech model. Instead, we adopted a co-creation approach. We work directly with local communities in Senegal, as well as social researchers, linguists. And the goal was to build both data sets and speech-to-text system that it really reflects how people use the languages. So this approach help us to use technology that reflect like a really linguistic practice. So we started by collecting data, and to ensure that the system reflects really healthcare practice, we collected really clinical conversation. This we maternal have consideration, or rather than just collected data in the control environments, we also ask people where they are to collect data. And then we paid like a close attention to the representatives to balance a little bit the representation, ensure like we have like gender diversity on both training, validation, and the text. So, and also we make sure like the data set capture authentic condition, including the background noise and spontaneous speech patterns. So after that, we use some for the pre-processing steps. We applied different techniques such as lowercasing, canonical number formats, and also we remove punctuation. And finally, we perform the spelling standardization. And this is like the most important because in language like Wolof, orthographic variation is very common. So we really need to do this standardization. So following the preprocessing, we apply like the data augmentation that helps the model to improve the robustness, especially when we are working with limited data. We apply different techniques as well, such as speech perturbations. We also added like background noise. So all this technique was helping to improve the data sets, and we ended up about around 10 hours of data sets. So we use different metrics. We use different metrics such as word error rates, which is a metric used to measure how many mistakes a speech recognition can make. In short, it just calculate like the percentage of words that are wrong, missing, or they are added to the correct transcription. And second, we used the character error rates. which is like the same, but it's just applied to on the character level more than on the word level. So recent research has shown that we cannot just rely on these standard metrics. So we had to introduce like a custom metric that can only focus on critical medical terms and we came up with keyword error rates. So first, what we did, we just identify like the helpful related terms in the sentence, and then we use the fuzzy matching. The fuzzy matching is like a sliding window search, where we are going to select the closest match based on the Levenstein similarity. In short, Levenstein similarities just tell us how similar two texts are. So, and finally, we compute the character error rate on that word. By combining this metric, we obtain like a very more comprehensive and context sensitive evaluation of system performances. So before fine tuning, we start by benchmarking different ACR models, and we use different metric as I just said, and the criteria was like we have to fine tune the model that has below 50%. But after that, we just say, okay, we are going just to select the first one, the three best model per architectures. And then you can see we fine tune three different models. The next slide, yeah. So we fine tune three different speech recognition model on Wolof. And we use technique called LoRa. LoRa is like a lightweight fine-tuning method that's it helps just to update a small part of the model. So and this it helps drastically to reduce the number of parameter you have to train, because we are like in low resource languages, we don't have enough GPU, we don't have enough data, so we have to find what is like the best approach to fine-tune these models. So at the first graph, you can show, you can see the training and the validation loss. They are decreasing over epochs, and this indicates that the model is successfully converging. And the second graph, you can see like the reduction in WER, which is in orange color, and the CER, which is in blue. The results show that our annual model achieved the low results, the low error rate. So this is that it helps us to outline like the importance of selecting a model which has a reasonable baseline. So it means when the model already have a reasonable baseline, when you adapt it, it will converge more rapidly. So after that, we had to do the human center evaluation, because our standard ACR benchmark are very useful, but they often fail to capture real world condition. So to address this, we conducted a human center evaluation. We used like about 1,000 sentences collected from the community members in their everyday life in different regions in Senegal. And then after that, we do the evaluation to see if our model is giving the best performance. And you can see on the curated test data, the model achieved like 20%, 25% of error, that is WER. And on the community recorded data, it goes to around 31. So this represents approximately about 35% increase. So the results are like that even we train the model, it can struggle when it comes to the conditions that are not curated. So this is like it shows like the importance of robustness, domain adaptation. and also the evaluation with really people and really condition. So after that, we try to understand what are the mistakes our model are making. And what is interesting here, some of error are not just coming from the system, saying like the system is failing to recognize this word, but instead there are some of the orthographic or phonetic variants. For instance, I can show you, for example, the word clinic, which I will say is like a boring word. It is like a code switching word. It means it's borrowed from French. And people, they don't really say clinic in Senegal. They will say clinique. So, and this error is due to the accent and the code switching. It's the same also with pediatry. So most of the error were coming from natural speech patterns, also for regional accents, and some error also are coming from the audio quality. So this highlights like this help us to understand like model not only fall on error, but also on some also linguistic diversity. So we are going to unlock some of the limitation of our work. So first, our data set is small and is only focusing on the maternal half keyword. So, and on this work, we try just to prioritize linguistic validity and domain relevance more than the dataset side. So as a result, the model has limited generalization to some of the conversational speech or topic, because as I mentioned earlier, we just started to collect a different maternal half keyword. So it means there is a limitation. The model can understand very well just this limited number of keyword. Even it can try to generalize, but it's something we really need to see if we can improve. But despite this limitation, the dataset provides a strong foundation for domain-specific ACR, and it highlights that the importance of community-centered approach for low-resource languages is very crucial. Looking ahead for the future work, we aim to expand the datasets by including more speakers, and finally, we aim also to extend our approach to additional Wolof dialects. And then, yeah, and also something we are going to see if we can do the same on other languages. So after that, we have our tool, which is Nakala, that is helping us to do the transcription. This tool is online now. We are going to give you the link, and it helps just to people such as researchers, doctors, and everyone who has like this audio clip to have the transcription. So thank you, everyone. I'm going to give you back the speech, Yann.
Yeah, no, thanks, Anthony. Over to you, Oche.
All right. Thank you, Tony, and hello everyone again. My name is Oche. So today I'm going to be talking about our project called Afristereo. So Afristereo is basically model evaluation stereotype datasets for bias evaluation in large language models. Next slide, please. All right. So there's a representation gap in some of the evaluation and training that's with AI right now, because most of this AI training and evaluation relies on data sets that are gotten from the global north. And these contents are usually produced in English and other dominant languages, which means that a lot of African languages, cultures, our contexts are hugely underrepresented when it comes to NLP and LLMs in general. Next slide, please. All right, so these data gaps can cause real-world harms, and the implications could look like, in healthcare, for example, where when you have like an AI triage to there's a tendency to under-prioritize Black patients as a result of, data linking them to higher pain tolerance, or in finance where a credit scoring algorithm could flag rural users because of bias patterns that could label them as high risk, and also in education, for example, where where African context and education isn't taken into account, the models could potentially flag their answers as wrong simply because simply because it's an African context, thereby lowering their chances for scholarships and opportunities as well. Next slide. All right, so this is where Afristereo comes in. So Afristereo is a project that we worked on to close the gap, and it's inspired by previous work by Deb et al., which introduced the SPICE methodology in India. And it's an open source data set that is built from community engagement. It was gathered across various African countries, including Nigeria, Senegal, and Kenya. And the mission of this project is to make AI bias evaluations global by including our context, our realities, and the real world context that we experience here in Africa. And our methodology is as follows. So we launched open-ended surveys, and then we're able to collect stereotypes from these communities. We collected the stereotypes in French and in English. And but in order to have like a standard pipeline, we decided to translate the French responses into English so that we can have like a unified model evaluation. And then after that, we use NLP models to analyze the stereotype, to analyze data leakage and also stereotype leakage. And then we were able to, and then we also try to refine our methodologies and for future work. Yeah, next slide, please. All right, so this is our methodology. So we launched the open-ended surveys on a platform called Luca. It's a Pan-African platform that is used for data collection and also for user insights. And then after that, we distributed the surveys via social media, emails, and personal outreach as well. And then we asked the respondents for stereotypes that were linked to specific categories specific categories across gender, age, profession, ethnic groups, religion. And then beyond these categories, because we didn't want to have like a very rigid or static data collection methodology, we decided to, give an open-ended section where respondents could actually share any other stereotypes that they may encounter. And the image by the right shows some of the how we collected the data on the platform. Yeah. All right, so this was the results of our collection. So we're able to collect 1,164 unique stereotype pairs, and we're able to get them from about 107 respondents across the 3 African countries, Nigeria, Kenya, and Senegal. And we were able to classify this stereotypes based on gender, religion, and ethnicity. And some of the recurring attributes that we had in our collections were stuff like Nigerian people love money, Nigerians are smart, stuff stereotypes like that. So after some cleaning and touching up, we're able to extract the identity terms and also the attribute groups. So we had very should I say unstructured sentences. So what we wanted was just the identities, and then we also wanted the attribute groupings. Yeah. And this is, So we also had various attribute groupings that were prevalent in our collection. We had intelligence, wise, strong, aggressive, emotional, coming up as the most common themes in our grouped terms. Yeah. Next slide, please. All right, so these are some of the regional stereotypes that we had. So we were able to go into, the various identity groups within the various countries as well. So we had ethnic groups like Igbo people being associated with attributes like being business-minded, Yoruba people in Nigeria being associated with things like loud, same as for Kenya, Senegal as well. There were certain stereotypes that were associated with them. And then we also had religion-based stereotypes that were also represented in our collection. So we had Christians as being, some of these stereotypes are offensive, but we had Christians as being associated with peaceful, and terrorists being associated with, Muslims being associated as extremists, or terrorists, are aggressive. And yeah, next slide, please. All right, so now this was the part that we had to do where we did the language model evaluations, where we used the data sets that we collected and the stereotypes to kind of like probe LLMs to figure out if they had preference for the stereotypes. So now we obtained the stereotypes, and then we wanted to use a methodology called the stereotype and anti-stereotype pair that was first introduced by Nangia et al. And the idea is that, given a list of identity terms and stereotypes, we create stereotypical sentences, and then we have the anti-stereotypes, and then we use a model, and then we use the models to kind of like obtain the corresponding value that the model will associate each sentence with. So if the model gives the stereotype a higher probability, that means the model is leaning towards the stereotype, as opposed to, giving the anti-stereotype a higher probability. Next slide, please. So for example, we had stuff like men are strong. So men in this situation now is the attribute, is identity, and then the attribute is strong. So we were able to form a stereotype sentence from that, men are strong. And then we also formed the anti-stereotype, men are weak. And then using a novel metric, we were able to calculate a bias score where we got the model's log probabilities and also the log probabilities for the anti-stereotype and the stereotypes. And we did the kind of like a subtraction of that. So if it's the higher the bias score, it means that the model favors the stereotype, and when it is highly negative, it means that the model favors the anti-stereotypes. But we were looking for kind of like a value that is balanced around the 0. That would mean that the model does not associate or have proclivity towards an anti-stereotype or a stereotype. All right, so we were able to choose, we worked primarily with open source models because we wanted to assess the model weights to get the probabilities. So we used open source models like GPT, GPT-2, GPT-Neo, Flan, BERT. We also use domain-specific models like BioGPT. And as we continued our work, again, we also evaluated more recent open source models like the Phil by 3.5 by Microsoft. We also did some for Mistral as well and other models. Next slide, please. So these were some of the results from our evaluations. So the GPT-2 models had higher bias preference ratios, meaning that they were kind of leaning towards the stereotype as opposed to leaning towards the anti-stereotype. So that suggested that there was some kind of bias that these models were already associating the stereotypes with. And then we also had models that were kind of like at 0.5. And we also had models that were towards the lower values. Yeah. Next slide, please. And so we also had, due to some of the limitations in our collection, because we wanted to have more contextual stereotypical statements and wanted to cover more identity groups and terms, because a lot of the surveys on the represented minority identities. So there was sort of like a consistency problem. So what we did was we generated more stereotypes and anti-stereotypes using LLMs, and then with human in the loop validation, we're able to validate some of these stereotypes with culturally informed reviewers that we had in our team. And we found this very useful because due to this augmentation, we're able to scale our initial data set from about 1,164 to more than 5,000. So these are some of the models that we tested. We were able to prompt the models to generate some of the stereotypes that we wanted, and a lot of the models, these were some of the results that we recorded from, probing the models to produce stereotypes. Some of them didn't want to produce the stereotypes. Others, like DeepSeek, were able to give us the very contextual and very negative stereotypes, if I may say, that we wanted to, use and test the LLMs. Next slide, please. All right, so these are some of the stereotypes that were generated through our augmentation, some very offensive. So we had statements like Fulani headers are always armed and looking for fights over grazing land. So this is common in Nigeria. It's a common stereotype in Nigeria. So we're able to get this and, to use in order to kind of like probe the models more, to have more contextual understanding of, the identity terms that we're missing in our initial data collection through the open-ended surveys. All right, so these are some of the results and insights. So we expanded our data set from 1,000 to over 5,000, and we're able to improve coverage across the various identity groups that were kind of underrepresented in our initial phase. So we had improved coverage over professions, ethnic, genders, and but this doesn't go without limitations, right? So we had some limitations because the synthetic data may lack authenticity, and the models can hallucinate or repeat patterns. So what we did was we made sure that we had expert human reviewers in the loop to make sure that they were kind of like annotating this and validating some of the stereotypes that we generated using the LLMs. Next slide, please. All right, so the next steps as a result of we are trying to generate more balanced anti-stereotypes.
Hello. Did we lose Oche? Yeah, thanks all. Can you still hear me though? Yeah.
Yes, we can.
Yeah.
We can, I think, just frozen maybe.
Yeah, Oche is frozen. Sorry, Oche. I mean, it was just at the end, so I can step in on that. But I guess one of the key things for us on Afristereo would be to do the data set in local languages, because we've seen that a lot of the stereotypes are actually expressed only in local languages and there is no real translation. So that's one of the next phase. And obviously then it's also testing different approach where you can have people sharing what they see, but also trying to have the lens of people who have been victim of stereotypes, and the perception also of people maybe spreading those stereotypes, or at least hearing those stereotypes in the communities. Because I guess depending on who you talk to and who has been, victim or not of the stereotype, the perspectives changes a lot. And so this is what we want to understand. This is not something that is fixed, and which is really hard then to represent in a data set, but you need to have an entire context and system to map around the stereotypes. And obviously, one of the key things that people were asking us, notably local creators of different chatbots, is that how can they mitigate their own models, notably models that they take from OpenAI or Gemini and so on. How can they do mitigation on that? And so this is why we're developing different, testing different methodologies on that. Okay. You can find all the data set and code on GitHub. You look for Yuke's Cultural AI Lab, and you'll find there, and probably the link is also somewhere on the web. So feel free to have a look and check it out. And over there, we have both the raw data set that is a human collected, and then after the augmented data set. We separated the both so that you can play with both separately. All right, cool. Then moving on into something that is a bit less machine learning driven in the beginning, but what we're already trying to understand, notably as designers and researchers, is how you evaluate not only the models, but once you have the product in the end of people, how do you evaluate if this product is safe, relevant for the context, and so on, and how can we adapt methodologies so that we test products and models then to some extent to the closest of the real usage that people may have. And so we started doing that a year and a half ago on this project, co-designing a chatbot for maternal health when we have a group of people sitting in a room. So it's really methodologies taken, from the UX research field, when you really try to have adversarial testing of the LLM on different topics. We refine this methodology. Right now we call that cultural teaming, borrowing from a team of researcher that actually got a methodology to be very adversarial, so do red teaming, but on the cultural aspect. And for us, that's very important because it's all about defining the right scenarios that can really challenge LLM in a real world context. And obviously, the closer the person are to living the scenario, the better it is. But sometimes you don't have the time to wait for the 6 months or the 9 months. If you look at the case of maternal health, you don't really want to wait in 9 months to start having results, or at least proxies of the result and potential danger of different chatbots. So this is why we try to condense these results by developing this methodology. So I'm not going to go too deep into this project, And just to tell you where we come from, but basically you could see this chatbot, and sorry again, because the project was in French, but you can have a lot of feedback coming up in terms of priority in the things that needs to be changed in the model. And so through prompt engineering, we've been able to improve the model little by little. What we're looking at right now is that how can we scale this type of methodologies, and notably maybe able to focus on specific themes, so refine scenarios, refine approaches on different domains, notably not taking health as a general domain, but being very specific. The second thing is the segmentation. A lot of the things that have been done around the African ASR community, NLP communities, has been through annotators, which was community driven, but a lot of this work has not been very precise in terms of segmenting who provides the data or who does the test, who provides the evaluation to some extent. And this is where we believe there is, I mean, coming from the field of doing user research, for us, you know, the segments of participant is very key, because otherwise you may introduce new biases in the data set that you collect, annotate, or just in the evaluation that you run. And lastly, obviously, is how also you can give back to the communities that you test with and how you get the data. And this is, in a nutshell, why we creating a new platform that's called Kitala. And I'll let Mam just do a demo, because we're really looking for feedback these days. So the platform is for researchers to use. So we're launching a new project with the Gates Foundation with the goal to do live testing of LLM across Rwanda and Senegal. But the particularity of that is that we don't want to look at it in a static way that generally a benchmark data set looks at it, but we want to look at it in the conversational way, which means multi-turn. And so the big research questions that we have is that how can you assess multi-turn conversation? And obviously then what are the metrics that you actually look into? But then also, once you have the recording of those different turns of conversation, how can you synthesize that into maybe a single turn data set, or at least a data set that you can then provide to the community in open source so that they can run evaluation of their model without the need of going to real participants all the time. But I'll let Mam Kumba take it from here if you're there.
So just like Yann was sharing just now, the goal of our platform is to scale real-world evaluation of large language models. So as you all know, generally when we talk about evaluation of large language models, we're thinking about statistical metrics or benchmarks, but we are really trying to, sorry, can you see my screen?
Yep, we can.
All right, so we're really trying to test large language models in real context, and to get how they perform in real scenarios, taking into account the cultural context and the local context as well. So our platform for now, we are trying to scale some of the methodologies that we've tested previously, like cultural red teaming. So we've built this platform where we try to allow researchers to create a red teaming session that is online and that can be scaled to a lot of users, hundreds or thousands. So we're really trying to operationalize our testing methodologies. And an example is this project, which is just testing how large language models work in educational use cases for very specific demographics generally in African context, and seeing how they can understand the cultural nuances of African students and also the languages. So like Yann explained the methodology before, we generally try to have scenario that we give our test participants, and we ask them to follow the scenario and have a conversation that they can then evaluate one by one with the LLM. So like just really quick, some of the metrics that we've been testing so far are just include I would say regular metrics like clarity and trustworthiness, but also cultural resonance. But the most important part in this is that we're trying to get really granular evaluations on response by response level, and also trying to get the observations, the comments of the people that are actually talking to the LLM. And all of this is something that that's pretty modular, that our researchers can set up by them on their own with the platform that we've built. So I guess one of the most important parts of our platform is allowing people to create specific segments of test participants, again, borrowing from the social sciences, like Yann explained previously, but we want to allow AI researchers or product companies to test with really specific demographics that we also help handle the recruitment of. But basically, yeah, we have this platform that we're developing right now to help with our live testing of large language models, and it is still in the works. So any feedback or comment that you have will be very helpful. Anything you'd like to add, Yann?
No, it was perfect, and we just had time as well, so wanted to make sure we leave time for the questions.
Okay.
And I guess, you know, these type of platform also generates a lot of questions on the approaches, on the methodologies, on the metrics, and also on the question, how often do you ask people to rate a conversation versus creating so much burden for them and cutting the flow of the conversation. But yeah, so that's all of that. But thanks so much, Mamkumba, for sharing, and thanks to the team. I guess over to you guys. Very happy to get any feedback or comments or questions.
Okay, thanks very much, everybody. That's really good.
We can't hear the clapping though. We can see you clapping, but we can't hear it.
Teams somehow cuts out clapping. I don't know whether that's deliberate or not.